Next up, let's talk about sets. So our set is an unordered collection of unique items, and sets are always denoted with curly brackets, and they are mutable, meaning that they allow modifications after creation. So let's have some examples of sets regarding the syntax. So for example, let's say that we are having a set of numbers or a set of marks. Actually, you can have a set of marks, and let's say that we are having marks like 90, 77, 88, and maybe 94, and lastly 97. So when you look at this variable, the fact that we are working with the curly brackets, that means that this is a set. And just like we did initially, we can always confirm the type of this variable by accessing the type function and having this variable tested out. So we are going to access our file, which is python then sets.py. It's python then set.py. So I think it's better if we have this updated. So you can see that the type of this variable is a set. And we can also go ahead and output this current set. So you can see that the items in the set are 97, 88, 90, 92, and lastly 77. So items in a set are always unordered, so the order doesn't matter. We can now have a look at the different operations that can be performed on sets. So regarding the operations, the first operation that we are going to look at is the union operation. And regarding this operation, it deals with combining two or more sets into a new set. So for example, let's say that we do have another variable that is going to store results of a test. So let's say that it's called tests or test marks, such that regarding the test marks, we are having maybe 70, 68, 81, and maybe 73, and then lastly we can have 77. Now for us to create a combination of these two sets, you should know that sets always have built-in functions by default in Python. So for us to perform the union operation, we are going to access the marks variable, then we add a period or a full stop operator. So dot. So when you add a period, you can see that these are the different functions that can be used. So in this one, you want to access the union, and it's always a function. So it returns the union of sets as a new set. So we are going to pass in the test marks. So for us to be able to look at the output of the union, I think it should be better if we have a variable that is going to store this union of the sets. So we are going to have a variable called final marks, let's say. Okay, we can just have this as marks union, such that it's going to have the whole combination of the two sets. And having created that, we can now go ahead and print the result. So you can see that the variable is having a combination of all the marks, both the current marks and also the marks of the test. So that is it with that operation. We can now move to the next operation. So it's all about knowing what you want to achieve and knowing which exact method suits that task. So the next operation is the intersection operation. Now regarding this operation, it's always related with finding the common elements between two or more sets. So we are going to find out the common elements between our current sets. So for us to achieve this, we are just going to have this copied out and pasted here. Then instead of marks union, this is going to be updated to intersection. And for cases whereby you want to find the intersection between two sets, we work with the intersection function. So this is going to be updated to lower case. And having updated that, we are now going to find out the output. Now when you look at our current sets, the test marks and then this other marks, you can see that we are having 77 as the common element or the common item in both sets. So we believe that 77 must be outputted, and right, this is what we have. So 77 is the common item between both sets. So we can now look at the next operation that can be achieved on the sets. So the third operation is the difference. So regarding the difference operation, it is always used to find the elements that are in one set but not the other set. So we are going to find the difference between the current sets. So instead of intersection, this is going to be difference. So this is going to be max difference. And just like these other operations, we also have a function that is used to find out the different elements. So this is going to be max.difference, and we can now go ahead and look at the output. So when we perform this operation, it prints out elements that are in our current max set, which is this, but elements that are not in the test max, as we have seen. So you can now see that 97, 90, and 92 do not exist within our test max. So regarding the difference, most of the times you can always find out the symmetric difference between the sets, and it is always related with finding the elements that are in either sets but not both. So similarly, we are just going to pass in, instead of the difference, we also have the symmetric difference, and this is going to be updated to symmetric difference. Then we can have a look at the output, which is this. So regarding the set operations, we can also add a new element to the set. So for example, let's say that we want to add a new test mark, which is going to be 100. So one, you always access the test mark, so test marks dot, and for us to perform this operation, we have the add function, so dot add, and then the new element that we want to add is 100. Then having updated that, we can go ahead and print it as test marks. So it goes ahead and adds the 100. We can also look at the remove operation, and just like it sounds, it is always used for removing an element from the set. And for us to remove an element, we can still remove the newly added item, which is 100. So you access the test mark variable, then you access the remove function, and then at this point of time we can pass in the value that is going to be 100. And then lastly, we can also look at the pop operation on sets. So this is going to be pop. So the pop operation is always used to remove and also return an arbitrary element from the set. So instead of remove, this is going to be pop. So we can go ahead and run this out. Okay, so we also have to go ahead and update this so that we have a look at the output for each case. So you can see that with the remove function, the value 100 was removed, and this is what we remained with. And then when we applied the pop, it went ahead and removed the 81 value.